Hi, good afternoon again. I will start by presenting the main main formulation of the model and how it was calibrated and developed, and how we benchmarked the results for with international institutions. The main objective of the model of this first iteration was assess the role of international freight and related CO2 emissions at global scale that will result from different scenarios that will derive from transport or trade configurations. If we have more multilateral trade or more bilateral trade, or if we keep the business as usual as we have nowadays, or assess what would be the performance of the current available infrastructure for the expected development in trade volumes in the future. Then the source of this study comes from a global equilibrium model, a trade equilibrium model developed here at Economic Directorate at the OECD that developed trade projections from 2004 to 2060 for different trade alternative scenarios for different 25 regions and 25 commodity groups that will in value. Then we need to translate this into transport volumes, and this is the role of this modeling tool. The modeling tool that was developed for this purpose, it's based on a four-step approach, but it's four steps, but it's nothing related with the traditional four-steps model. But it departs from the international trade projections from 25 regions and 25 commodity groups. 19 of them are transport-related because we have economic flows, etc., that are also addressed as a commodity. And the first step of this model is to convert these 25 regions, flows between regions, into a more discrete spatial characterization that we need to identify which are the consumption and production centers around the world. For that, we developed a methodology that we'll present next, and how to determine the centroids on location around the world. The next step, this allows us converting an original OD matrix of trade from 25 regions into 294 regions OD pairs. With this, we move to the next step. It's identifying how much value is being transported by each mode, and we'll present how we develop this, and then how we convert this value into weight, how much freight volume is being transported by each mode. And then the last step is assigning this into a real network that was developed for this purpose. The main outputs at the end of this process is having for each time step, that is in this case done every 5 years, of all the international trade volumes and weights by OD pair and mode from 2010 to 2050. As I was telling before, the first step is then we have a very aggregate characterization of the world in 25 regions. Some of them are multi-country. One thing that's important is to say that these projections are for international trade. Then we don't have domestic trade freight included here. But in these regions are very aggregate. In the case of Europe, it clusters altogether the EU 15. In some other countries, it's one region is a country like the US or China. But even though this is very aggregate, what we need is first to identify which are the centers of production of consumption. And for this, we use available information about the population distribution and GDP distribution concentration around the world, allowing us to identify which are the centers of production using an optimization tool, and as a very aggregate constraint, saying that we will not have more than one centroid every 500 kilometers within the same country. We might have centroids that are closer than 500 kilometers, for example, especially in Europe, but they cannot be within the same country. Here we have the GDP concentration map around the world that led to the specification of centroids. These centroids are located in cities over 500,000 inhabitants in 2010, with some exceptions where we had regions of the world that they only had very small cities, and we had to artificially add some potential centroids. Then at the end of this step, what we have is we converted the aggregate OD matrix from each year into a very detailed centroid-based approach that we are able to compute the flows between the different centroids for the different type of commodities from 2010 to 2060. This is the output of the first step of the model. For moving for the next step that we need to assess, one thing that is very important is travel times and distances on the network between the different centroids. And this has been one of the main additions of this modeling approach, is develop a real network model for freight movements around the world. For this, we integrated online free available databases that normally they are unimodal. We had to create a multimodal system that incorporates, I'll not go in detail saying the sources, but they are detailed on the discussion paper that you have available in the back. That integrates for the road network, the main highways or main roads around the world, where we can see it's the top map. It's a very detailed specification of and very scattered around the world. In terms of rail network, we considered all the stations, and rail network also specification, if it's double track or if it's electric track, and even the gauge. And then we have a higher concentration of network available in Europe and the US, and less a less detailed network in other continents, and that is the downwards network. In the case of for sea, for maritime routes, we used an available routing network available, and we identified all the international ports that could be a source of international trade, and which are routed through the network that is presented in the top. And also in terms of air, all the international airports were also considered as potential source of freight movements, and also the commercial flights were coded using available information. All these networks normally are scattered, and our main contribution is joining them together in a single GIS platform, and also create the links between the different modes, create the intermodal links that will include dwelling times that were calibrated for different countries, and also the links between the centroids and the infrastructure, normally through the road or rail links. Moving forward, as we saw, the first step is spatial discretization of the trade. The next step is identifying how much value it's being transported by each mode. For that, we use the standard multinomial logic approach, which is a standard discrete choice process based on available information from exports from Eurostat and ECLAC from Latin America, that allow us to calibrate a model in value from 2004 constant US dollars that allow us to estimate how the value it's being shared from the different modes considered, rail, road, sea, and air, for different freight movements, including the specific network specification that will be the shortest path by a specific mode to link one centroid to another, and also some economic variables, and also some additional elements as this existence of trade agreements between origin countries and destination countries, the export country and import country, and also the existence of a land border as an element. All these elements prove to be important for the mode choice process. Here are the results. We'll not go into detail. This model also contained a panel term for commodities. It's like saying that each commodity type has a plausibility or an intention of using more strongly C than other modes. We have some commodities have in this term positive or negative, if it's more plausible to use it by C or not. In the main attributes of the model incorporate distance and travel time for the different modes. We should highlight that we are not incorporating costs now and this stage of the model, and also the context variables, as I told, that the existence of trade agreements and land borders that favor, for example, connections by road or rail. At the end of this step, we convert then the trade volumes by commodity type for each year, adding that the travel time and distance that come from the network model and the geographical and trade specifications that come from scenarios. We are able to estimate how much trade between OD pairs is being it will be happen. It's expected to, it's been modeled to happen between 2010 and 2050. But then we have to convert this value into weight. How much weight is being transported, how much tons are being transported. For this, we developed a weight value model that was calibrated for each mode of transport, using again the same data source from Eurostat and ECLAC. And we specified a model that we don't go in very too much details, but is a discrete model that estimates how much tons are converted from $1 to how much tons are being converted by each mode. In this model, we integrate also the network data. It's if we are transporting goods more further away, it's a more weight-intensive trade or a less intensive weight trade. The geographical and cultural variables, as if the countries speak the same language or not, that also proved to be a relevant issue, and the economic profiles of the export country and import country. If we are importing to a poorer country or a larger economy, this also has an impact on how much the value-weight ratio converts. Here is the model specification for each mode. We'll not go into much detail because this is not the purpose of the meeting, but we should highlight that, for example, the effect that time and distance have again, it's different for each mode. As we can see, for example, in terms of C, the only important term that convert to this conversion ratio between weight and value, it's the time and not the distance. In other modes, it's the combination of both effects. Also, it's very important, we highlighted in some modes, it showed very relevant the presence of trade agreements that will create more value added goods that with the same value they are transporting less weight than they are greater value goods, and also the presence of the same language that allow us to transport also greater and larger volumes of goods. At the end of this step, then we are able to estimate how much trade in weight it's been transported from each OD pair of centroids by each commodity type from 2010 to 2050. It's this who is being assigned then to the transport network that was presented using a shortest path approach. Just to make a first validation of the results of the model, we computed a model from 2010 to 2050 for different trade scenarios that will not describe in detail here, but we benchmarked the results for the baseline scenario for 2010 with available sources in terms of trade volumes that are being transported and weights. And we can see that the model estimates are consistent with available data sources, either in terms of freight volumes, but also in CO2 emissions that were also assessed with this model. And after this, I'll stop just for a few minutes if you have some clarifications from the model.
Maybe we move ahead to present the results of the model, just to make sure that we get it filmed as well. So just to highlight some of the highlights of the model results in terms of what we can do already now and what's presented in the outlook. Looking at the global trade in value, the global trade in constant value will grow by a factor of 4.2 by 2050. This will translate into a growth of 4.3 actually in terms of the volume of that the trade measured in tonne-kilometres. And why is that? Actually, the weight of the trade will decline slightly, as goods that we're transporting will be of higher value, lower weight, but at the same time the distance traveled will be increasing over the global levels. So you'll see the shift in the balance of trade where it takes place. We're moving slightly lighter goods, but more value to higher distances than before in the overall results. This will certainly set an increasing capacity constraints, which can have an impact on economic growth in regions. There's also a strong growth of CO2 emissions, nearly 300% at the global level, which obviously undermines then some of the climate change goals we have at the same time. Now looking at actually that global freight, 83% of that freight will take place by sea by 2050 in terms of tonne-kilometres. But if you look at the CO2 emissions coming from the global trade, it's actually more than 50% will come from road freight because of its being more CO2 intensive mode of transport compared to maritime. But overall, we do think that this is setting an unprecedented challenges for not only for trade but also for the transportation system, especially at nodes, ports, hinterland connections, etc. And we need to tackle these challenges. Now here you see a map of let's say the main trade corridors or trade areas, and the bars on the left are the orange ones are the freight in volume, and the green one is the CO2 emissions in 2010 and 2050. And what you see here is that the North Atlantic route, which is the main route today, will still be extremely important. It'll see a huge growth in volumes by 270% by 2050. However, it is also interesting to note that the North Pacific will actually replace North Atlantic as a main trade corridor already by 2030, based on our underlying baseline scenarios for trade growth. This really confirms the shift of economic balance to Asia, to East, and the center of gravity for economies to really shifting that region. We also see a significant growth in Indian Ocean route, trade between Asian economies, Southeast Asia, but also between Asia and Africa, growth by 400% by 2050. We're not highlighting here also the trade between Europe and Asia is increasing through the Suez Canal significantly. We see nearly 300% growth on that link alone. But what we also see is a lot of the intra-regional trade increasing, especially looking at intra-Asia, 400% growth. The growth is much more higher in Africa, 700%, but from very low levels compared to today. But if you look at the intra-Asian trade, what's important there is that actually the CO2 emissions will grow by 330% around by 2050. And why is that? It is mainly driven by the fact that we don't have alternative transport modes available for that intra-Asian trade. We only have road links available. And this is really a contribution. I would say not only, but in the modeling framework, the main mode of transporting goods between these Asian regions is road. There are some rail links, but in our modeling framework, they are not capable of delivering these goods at the current levels of quality and time and speed. The other contributing element to that is actually trade from ports to hinterland. And when goods don't stop only at ports, they leave from ports somewhere to the consumption and production centers. And here, again, road is quite often the main mode of transport. So increasing that intra-Asian trade will really result to a significant CO2 emissions in intra-Asia. As I mentioned, we also see a huge increase in port volumes as a result of an increasing trade, averaging 4 times of the growth compared to today, but very significant increases in China and India, Africa and Asia compared to 2010 levels. We also looked at actually in our modeling shipping-based emissions in ports, we see fourfold increases in some of the local pollutants, except for the ones where you have already more stringent control mechanisms available in the industry already. But we really see some challenges coming at the port side as well. And as I mentioned, trade doesn't stop at ports. This is what happens quite often when goods arrive at ports and leave to the cities or production or consumption centers. And this link is really important, the domestic freight link to international trade. We see that the increased trade volume will really put infrastructure under pressure, especially from ports to hinterland connections. And obviously there are a lot of implications regarding road transport investment, traffic management, but also the CO2 mitigation policies. We need to be able to improve the emission intensity of existing fleets, but we need to also be developing alternative modes, alternative solutions for the existing freight, improve the efficiency of the supply chains, and introduce also new technologies. So looking at that aspect. And how important is that? Actually, the first time we were able to estimate what is the size of the domestic share of the global freight. How much of the goods are being transported within the domestic territory of the global trade. So we take an estimate of 10% of international trade takes place within domestic borders. This differs by country, obviously, depending. In China, it's actually slightly lower, at 9%, because of the coastal concentration of a lot of the production consumption activities today. In India, it's around 14% because of a more inland concentration of these centers. But this 10% represent about 30% of total trade-related CO2 emissions emitted today, and also in the future. And this is really driven by the fact that this transport is taking place by road freight, mainly from ports to hinterland connections. This is also the area where national policies can have an impact compared to the maritime link, where a lot of the discussions are on international agreements, etc., for reducing CO2 emissions. So this is really the national interest side of the decision making as well. I just have one more slide just to say overview of very broad policy implications of this type of work. Obviously, there's the need to improve capacity management. We still see many freight facilities underutilized or performing on under capacity. We will need to be investing in missing links, in alternative modes, but also in multimodal connections, and we try to increase that efficiency. We need to be preparing not necessarily for megaships, but I would say to more and bigger vessels, and also including not only the port area, but also the port hinterland connection. How do we make sure that we can deliver goods to the destinations? And as already mentioned, the vehicle utilization. There's a really room for improving the utilization of vehicle, increase the vehicle utilization and improve the load factors, and also reduce the idle times across the supply chains, looking at border crossings, looking at any interfaces you're crossing from port to hinterland, from between the countries, etc. That's where a lot of the improvements can also be made. So we stop here for a second if you have any further questions, and then we can... Yes, please go ahead.
Just a clarification. The only country that had available that information about the domestic link from international international trade component is the United States, and their value is around 16% of the total freight volume within the country.
And our model is exactly by accident.
Yes, not
the
always.
model calibrated well.
But that's one case.
Maybe just to follow up on that in terms of the combining the domestic and international freight, because we are estimating both sides of the coin. This is the idea that we'll be using that information, like in the case of the United States, where we have information available that 16% of that total freight taking place within the U.S. is linked to international trade, and our model gives the same results. We can then estimate the remaining part of the freight nationally, and benchmark the other part of the modeling framework, what we're doing to those numbers as well, to getting a complete picture that is comprehensive.
Just before we go to the results, highlight that what we've shown you here for the moment are aggregate numbers, but the model produces estimates by link and by node. So here are just the highlights, but they result from summing up across the links and the nodes. And we will be showing you a bit of that next?
Let's move on to look at some of the. We did two alternative scenarios, just sort of to initiate some discussion of what could be potentially done already with what we have today. Again, understanding that this is not perfect, this is still work ongoing, but we should maybe develop this further. So, Luis, do you want to give an overview of that?
Yes. We developed two alternative scenarios of potential developments in infrastructure. Then it's network level assessment to see the ability of the model to perceive how much these investments or the improvements may affect the performance of the system. And we tested two alternative changes separately. One would be the expansion of the Suez Canal, and the other, the improvement on the performance of the Eurasian rail corridors, that we only test some of the potential alignments. In terms of the Suez Canal expansion, it's predicted, it started already the construction, and it's predicted that in 3 years we have an enlargement in capacity, an increase in capacity. It will allow also reduced dwelling times at the canal, reducing from 11 hours to 3 hours in average, and also increase the capacity that will have having ships circulating both ways at the same time, increasing the number of ships per day from 49 to 97, almost doubling the capacity. As we told, the model is not very is currently or the path choice. Capacity is not one of the elements because we don't have congestion included. And what we assessed, it's the travel time savings that will result from this reduction in dwelling time at Suez Canal are not very significant at global level. Then we are not able to grasp the increase of capacity or reliability of this connection, just being approximately 1% at the global level and 2% at the local level. Then what we have is this has just an increase of the domestic component of some OD pairs. If we go on the product composition and the types of commodities that are being transported, the impacts are not very different by different type of commodities, seeing that the increase in flow in tonne-kilometres varies between 0.5 and 1.5%. Then what we can conclude is the model is not the current formulation, as we don't have capacity included as an element for route choice specifically. We have an inability of the model to perceive the travel time savings that are derived from this reduction in dwelling time, and this could be twofold. At the same time, as we are not including costs, it's expected that the fees may also increase. That will also can lead to a detour from ships or from the canal to other paths or other alternatives that's going around Africa, or also because we don't have the congestion term, the future growth of freight, we are not able to grasp the congestion elements and the gains that will be derived from this doubling the capacity of the Suez Canal. Then we see that in this case, our model is not able to grasp the gains that come from this expansion, just very slightly the travel time reductions that are not able to change completely the picture. In terms of the Eurasian rail corridors that are being studied, several alternatives, we just are considering 3 possible improvements or corridor or alignments that will improve the connection between Europe and Asia. The scenario that we tested, it tries to improve the interoperability problems, especially on the gauge, and also the border crossing. What we tested is if we are able to reduce 50% or reduce time on these elements, what would be the savings? and also improve the average commercial speed on the network to 60 kilometers per hour. And for example, this on travel time would mean, for example, from going to Munich to Shanghai, reduce from 4 weeks to 2 weeks. Okay, this is in terms of travel time. These travel time savings, what impacts do they have on the model? What we see is the disconnection increased very significantly the rail volume at the global level. Then it's saying that globally, rail share, it will increase 10%. The volume, it will increase 10% globally, and almost more than double in 2050 compared to the baseline scenario, specifically for the routes along these corridors. This rail increase will result from transfers also from the road, in some connections, but also from the sea. We have some transfers that will, instead of going through the Suez Canal, will start using this rail connection. We also see that this will increase at even we in the model we are considering constant trade values, but that we just are measuring the transfer of that into weight. We are seeing that this will have an impact also increasing 0.6% the total freight volume. That is slight. In terms of types of commodities, we also here we stratify by type of commodity. We see that some commodities as manufacturing, electronics, textile, mining, but especially livestock are the ones that are more impacted. Viewed specifically because of the panel terms that are included on the rail model that was calibrated. Then we can conclude also, we can assess also which are the economic centers or centroids that will be more affected by this by this change. You can see that they are mainly located at large urban centers in Europe and in Asia, but also some centroids along the way. What we can see also, this project may impact significantly the rail freight volumes between Asia and Europe, although this model does not incorporate costs. This model transfer is mainly just due to travel time savings that will also change the model choice process, and also the translation of this mode choice into weight of the different type of commodities.